Good morning, everybody. Patricia Dugan here. Thank you for coming to our Traefik online meetup today. We are super excited for you to be here and for today's show. Let me tell you who I am. I am Patricia Dugan. I'm the Director of Community and Community Marketing Initiatives over at Containus. And we are the creators of Traefik, the beautiful open source edge router and cloud native reverse proxy. And the goal of our online Traefik meetups is to bring you some cool ways with live demos that companies and cool developers are using Traefik to solve interesting technical challenges in the marketplace. So we are going to do that with you today. Show you something cool. I have a few goodies for you first. I would like to make sure you know a couple of things. One is that we have reached GA of Traefik Enterprise Edition, and it's now Docker certified. So if you didn't know that, now you know. If you don't know, now you know. We've also announced the alpha release of Traefik 2.0, and perhaps one of the most things that I would like to beckon to your attention is that we are looking for a US-based developer advocate. I am super stoked to meet this person. So if you know of someone that is a Golang expert and stoked to talk to people about open source and technology, please do send them our way. We'd love to chat with them. And I will also put in the chat box some articles about Traefik Enterprise Edition and the free early access that you can experience, as well as information on Traefik 2.0. So now let me tell you who we are speaking with today. This is going to be so yummy. I saw a demo of it yesterday, or a presentation of it, and the demos are dope. So today we are speaking with Jakub Coufal, who is the senior software engineer at Wandera, and he's going to speak to scale your TLS-sized API with Kubernetes Ingress. So get ready for an awesome show, and I'm going to hand Mr. Jakub the mic now.
Yeah, thank you for introduction. Hello, everyone. As said, I'm Jakub. I'm working in the company called Wandera. I'll just briefly go through what we are actually doing to give you a glance of what we are dealing with. So what the Wandera is, we are a company who's securing basically mobile devices of other companies. What we do is that we provide the endpoint, both the endpoint and network security to our customers. What it means in terms of technology is that we have actually millions of users, hundreds of thousands of devices running on our platform concurrently, meaning both mobiles, Windows laptops, and so on and so forth. We're running on 5 different cloud providers as of now, with tens of data centers all over the world, including Australia, Hong Kong, East Coast, West Coast of USA, London data centers, and so on. Running on hundreds of nodes, virtual or manual ones. And we are running currently 6 bigger Kubernetes clusters, or the regular Kubernetes clusters, and for our so-called edge clusters, tens of K3s Kubernetes clusters. In Wandera, we are kind of believers in DevOps. So in our 12 engineering teams, we believe that the teams should own their own services, and they should be not only responsible for the development of the service, but also for operating the service, for troubleshooting in production, and also to be able to release independently as a team their own services. In order to do that, we're utilizing the GitHub style deployment. So basically what you commit, that gets deployed. And we're also, and I'll be talking a bit more about that later, we are providing an environment where to test not only the deployment, but also the services in isolated environments. And we heavily utilize the automatic acquirement of certificates and DNS names together with the Traefik ingresses. We call that the feature instance environment, and I'll be talking about that a bit more later. I'm from a team that's actually responsible for making the regular or the feature team members' life easier. So in order to do that, we started to use that, to use the Kubernetes, to use the cloud-native technologies. And also some time ago, we decided to use Traefik for our edge Traefik solution. So all user-facing Traefik goes through it on all the environments up to the production. And we use the auto-scale deployment setup of the Traefik. We're not using daemon sets. We're not using bare metal instances or whatever. It works fine for us. We even auto-scale on few metrics. There, we utilize the Prometheus metrics and the open census tracing, basically via the open tracing bridge. And as I already told you, we supply the domains mainly for the testing environments via the external DNS component. So no operations guys need to take care of that. So it's all automatic. And also we utilize the component called Cert-manager for acquiring the valid TLS certificates for the services running within our Kubernetes clusters. This is just a sketch of our deployment. We're utilizing the private topology of the clusters. So basically all of our nodes are running in private subnets with just private IP addresses. They're not reachable from the outside internet. And we just utilize the ELBs or load balancers or any type of load balancers actually in the public subnets that are reachable from the devices, from the users. You might think that there might be like a performance penalty for that, as the requests need to hop a bit more. I would say that in terms of that, we didn't really it really didn't happen for us. So probably don't be afraid of deploying Traefik just as a deployment instead of running in every single node of your cluster. I would say that's kind of a lesson that we've learned. While I was talking about that feature instance environment, this is just a sketch from the dashboard from that environment. The name is kind of misleading, but what the feature instance environment for us means, it's a special kind of environment. It's actually a development environment where any of our developers can deploy Wandera, which consists of I don't know, 50 different microservices and all of the supporting infrastructure as, let's say, a single package into single namespace within the Kubernetes cluster. What it means for the number of objects, and so it means, for example, that we are running 2,000 ingresses and 2,000 services within the cluster, which caused us a few troubles regarding CPU and memory consumption, and so going through the roof. That's another of the lessons that we've learned. In terms of running Kubernetes and Traefik on the AWS infrastructure, there's a few takeaways or a few things that I would like to stress out. Don't forget to configure the proxy protocol, so you'll have the real IPs. And don't forget to add the trusted sitter to Traefik configuration. Without that, it didn't work. Also, we kind of learned that the TLS termination is more convenient to be done on the Traefik than to be done on the ELBs or ALBs, mainly because it's pain in the ass to manage the certificates on the AWS side. It's so much easier to manage it within the Kubernetes. Don't forget to set up connection timeouts. That might be obvious, but we kind of forget that and cause us a bit troubles. And a few performance takeaways, just very briefly. Don't bother with the packet hops, as you might find a lot of resources all over the internet. Like, yeah, be afraid of that. I wouldn't say don't bother with that until you prove it's necessary or it's a real problem. It depends really on your workload, actually. The CPU-based horizontal scaling that worked pretty good for us horizontally because the CPU kind of grows with the number of requests that are served, so that goes pretty well. If you need anything more specific, then you have the Prometheus bridge, and you could use any Prometheus metric provided for that. But the plain old CPU-based horizontal scaling didn't work. It's working quite fine. And the last one, be prepared to scale Traefik vertically with number of ingresses, services, and secrets within your cluster. The more you'll have inside, the more you'll need to grow with the Traefik vertically, as it needs to watch a lot more secrets, a lot more ingresses, and so, and it needs to parse that, watch that in the memory and everything. So that needs to be scaled vertically then. It's probably, it's not usually a problem, as you might be running like tens, even hundreds of ingresses, but in spikes we're touching even like 5,000 ingresses and so, and that then can prove to be a problem. Yeah, be mindful about the namespaces you're watching and try to cut that just to the bare minimum. And yeah, that would be it. So the first demo will be just deployment of a Traefik to already existing cluster. What I'll be showing is actually 3 demos in a row, basically. I have the Traefik deployment prepared. I have some test application prepared. And then I'm going to present or show you how you can obtain the DNS record for your service automatically, and how to configure the Cert-manager to work together with the Traefik to get the TLS certificate for your service as well. Let's switch to presentation modes. So there, okay. No, let's back on this. So the first thing I'm going to, I have the testing cluster prepared called Zoidberg, which we're running on the public domain. It's actually accessible, called Zoidberg Wandera CZ. And that's because if you want to get the real certificates or that we want to get the real domains, you need the real infrastructure. So that's real infrastructure. All the deployments or all the objects and everything that I'm going to present and show you, and I'll be deploying into the cluster, are present on my GitHub, and the link will be on the end of the presentation. And I think the slide deck will be shared after the presentation, so you can take a look there. If you deploy everything that's here, you should get the Traefik with the Prometheus test app, external DNS, and Cert-manager all working together. So you should end up in the very similar state as me. Okay, so the first thing I'm going to deploy Traefik. So let's do this. Just a few notes to the actual deployment. It's the regular style. It's the regular style deployment. Nothing really different on that. Just be sure to set up your termination grace periods correctly when you're going to scale up or down or anything. And if you're going to use the feature of generating the domain names for your ingresses, don't forget to set up the Kubernetes ingress endpoint in your configuration. You're using the host name type. There's two other options for that, if I recall correctly, but we're using this host name type, which basically means right now I have the CNAME pointing on the ELB in front of a Traefik with this name. And if I configure this in this config map, or in this Traefik configuration, or this actual Traefik configuration, the external DNS component is then capable of actually picking this and creating like CNAMEs for this A class record. So you can then basically reach it under that CNAME. Without those two lines, your ingress status won't get populated with this name, and the external DNS will not work. It won't work without this. So we've got this deployed, and I'm also going to deploy the test application, which I want to run on test Zoidberg Wandera CZ domain. So let's deploy that. Cool, we've got that, but we should not be able to see it or reach it. Yeah, as the domain does not exist yet. So let's switch back to the presentation. That was the deployment of just the basic app and Traefik. In order to get this domain or this public domain for application, there's this component external DNS. This is a diagram of how it works. The green lines are relevant to getting the service DNS record, and the red lines are related to actual Traefik DNS record. So basically, we have ELB that has this like alias record or this special AWS record in their row 53. Then we have actual gate Wandera CZ CNAME record pointing on that. That's actually generated by that external DNS as well. And we are now going to actually deploy that external DNS, as right now it's not running. So I'm going to deploy that, and it should automatically pick up the ingress definition and create the CNAME record pointing on that gate. So let's try that. So I have this external DNS. Again, it's just plain deployment with a few configuration options, which you might find out in documentation. It's in the GitHub, so you can take a look there, and also there will be links provided to the documentation provided at the end of the presentation. So let's deploy that external DNS. Everything created. And if we take a look into logs, we should see creation of the test Zoidberg Wandera CZ, CNAME, and TXT record as well. So right now we should be able to reach it. Yeah. Actually, yes, we're there. So you're now able to reach it through the domain that we've created by the external DNS. How that works in terms of actually picking up the host name, it's picking up the host from the rules. So basically anything you write here as a host, and it's actually resembling the domain or the domain filter that you specify in the external DNS deployment here. Basically, the domain filter needs to be a postfix of that host. It will get created. Also, it's picking the domain names not only from rules host, but also from the TLS host. So if you don't, you might actually want to reach your application through HTTPS on different domain than through the HTTP, but in most cases, I believe you don't. So just take care to have both names equal, so you don't get any surprises. Also, one last thing that we've learned using the external DNS and creating the domains out of the Ingress specification is to really be aware not to use the wildcard host names like this. If you do that, the external DNS is really happy with that, and it will gladly create the record, which might break your whole cluster pretty easily. This is not the case that you're probably going to do, I would say, but might be tempting to actually have the wildcard certificate for, let's say, Zoidberg Wandera CZ like this. And in that case, if you do this, it's actually the same. It will again create a wildcard record pointing to that gate. It might not be a problem, but it's not something that you're expecting when you're creating a single ingress for a single application, that your ingress specification for that single application will create a wildcard record for the whole cluster or for like all the services running under this domain. So just be aware of that. Back to the presentation. This was that external DNS that we have now working. So yeah, it's creating A or C name records for the ingresses or for the services. Like if you have a service of type load balancer, it's pretty easy to create also a C name for the load balancer or so. It's also capable of creating the SRV records for node port services. We're not really utilizing that, but it's like the other option. But really watch out for the wildcard domains or for the wildcard host. It's quite easy to burn yourself with that. So the next step, we would like to have a TLS certificate for our application or for our test app, for this to-do app. So in order to do that, or in order to get the certificate, we have a few options. One option is to negotiate with some certificate authority the certificate and upload it manually, or basically introduce it within the Traefik configuration file and use that one. That's useful for a case that, let's say, you have basically a fallback certificate when you don't have some DATs for your subdomain, and you want to have a fallback certificate. That's useful. Also, in the case that you're running any like more prod-like application and you want to have, let's say, extended validation certificates and so that's useful. But if you're dealing as we do with like thousands ad hoc ingresses and you need to have a certificate for each single one, then I would say the Let's Encrypt or like any like ACME solution is a way to go. How that works is that there's basically no user interaction involved. It's automated way how to obtain the certificate, and how that works. It's based on like challenge response protocol, where you tell Let's Encrypt, hey, I want a certificate for this domain, and the Let's Encrypt will tell you, okay, but I need you to prove me that this domain actually belongs to you. Here's some challenge. Present me the challenge on your domain, and I will get you the certificate. So how that works? There's like two options. Either you basically you introduce an HTTP endpoint on that domain, or you expose an HTTP endpoint on that domain and tell Let's Encrypt, hey, here's the HTTP endpoint with this challenge that you required, and the Let's Encrypt will call that endpoint. It will verify that the challenge is all right, and then you can get the certificate from them. The other option is to basically present the TXT DNS record within within some DNS server or through some DNS service, like again like AWS Route 53 or anything else actually. And the Let's Encrypt will then validate this TXT record, as the TXT record can basically contain any almost any text. So you're presenting the challenge within the TXT record. Utilizing the second approach, the DNS one, has a big advantage that you can also you can get you can get a certificate, the wildcard certificate from Let's Encrypt, as the Let's Encrypt can validate that the whole subdomain, or that you're an owner of the whole subdomain or the whole domain, while with that HTTP endpoint, it can validate just that particular subdomain. So it's more powerful approach. On the other hand, it's usually slower than to just present that HTTP endpoint. It's a lot faster. Also, be mindful about the Let's Encrypt quota, as there's a quota per top level domain, which in our case, the test cluster is called Zoidberg Wandera CZ. So in our case, that's Wandera CZ. And the quota is rolling 7 days window. And I think it's right now, they've changed it recently, and I think it's like 50 or something like that, which is not much. And yeah, again, if you imagine you're running the 1,000 ingresses and you want to that all of those will have valid certificate, you really need to stick to those wildcard certificates, or you need to create the certificates that have or has all the SANs within the request. But that's kind of tricky to do with the actual certificate manager. So last demo time, I'm going to show you deployment of the Cert-manager, which is, well, also pretty easy. It's just a few deployments, or an actual single deployment, and then a few airbag rules and CRDs. So let's first deploy that. So it's coming up right now. I also deployed so-called cluster issuers, which are those custom resources that the Cert-manager is utilizing or using. Those are basically descriptions descriptions how the Cert-manager should get the certificate. I have two defined within the example. First one's called Let's Encrypt Staging, and the second one is called Let's Encrypt Prod. Both are using the DNS challenge. They're using AWS Route 53 to present the challenge within this region. But the difference between those two is which Let's Encrypt server they're using. The Let's Encrypt Staging is using this staging server, which has, I don't know if unlimited, but like, let's say unlimited quota. So you can get as many certificates as you want. On the other hand, those certificates are not valid. And it's basically for testing purposes. So you can test that your whole integration with like this AWS Route 53 through the Let's Encrypt, through your Kubernetes cluster is working together, and you should get the certificate in the end with just this fake Let's Encrypt authority, which is not trusted. And yeah, the certificate is not trusted, but you can test that the whole integration is working without sacrificing your quota. So that's kind of useful to use. The second one, Let's Encrypt Prod, that's using the Prod API, which will get you the actual valid certificate for that domain, or a valid wildcard certificate for you. how you're able to use that within your Ingress definition. So we had this test app deployed, and we had this Ingress definition on it. So what it does, again, kind of automatically, is that it's watching all the ingresses. The Cert-manager is watching all the ingresses. And again, it's watching those hosts and this host. No, not only this host in TLS section. And it will try to create a certificate for test Zoidberg Wandera CZ within the Let's Encrypt. And it will try to save that certificate into the secret with this name. So this secret is actually now, it doesn't exist yet. And we want the Let's Encrypt to create it for us. So I hope it doesn't exist yet. I was testing prior up. And yeah, in order to get that, we just uncomment those two annotations. The first one is enabling the integration. And the second one is a hint for the Cert-manager, which issuer should be used. I'm using the staging one, so we should get non-valid certificate right now. So we have deployed that. Let's redeploy our test application. And let's check the logs of Cert-manager. Finished processing. Schedule for renewal. Okay, so everything should be up. So we should be able to reach our application through the HTTPS. Yeah, connection is not private as it's not a valid certificate, but we should have, yeah, fake Let's Encrypt intermediate as a intermediate certificate authority, and we have the actual certificate for test Zoidberg Wandera CZ. If I'll switch the Let's Encrypt to Let's Encrypt Pro, we should get the valid certificate for that domain. So back to the presentation. A few takeaways. You're also capable of creating your certificates upfront with the Cert-manager. Basically, how that looks is that you specify the certificate like this. You just specify certificate, Cert-manager, blah, 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 for those actual domains, which is a different approach than to have it automatically pick up from the Ingress. You might do both. You might combine both actually as actually what the external or what the Cert-manager is doing. It will automatically create this object from the Ingress specification if it doesn't exist yet. So that's what it does. Why is this useful? It's useful for case that you actually want to have this wildcard certificate, as it's a safe way how to create one. Then you can store it in, let's say, wildcard abstract, and you should get that. You might try to deploy that. There. wildcard. Remove the label. Okay, fine. Let's try that. And if we watch logs, I'm able to do that. Sorry, don't have enough permissions to create that. Doesn't matter. Basically, this is the way how you're able to create those wildcard certificates, and then you might use them within the Ingress specification by just saying the secret name or using the secret name of this wildcard certificate. If you're utilizing both the Cert-manager and the external DNS, don't forget to still have the host within the rules and host within the TLS without the wildcard, because the external DNS would create the wildcard domain, which you don't want to. So that's the last demo, and as just a closing note for the Traefik 2.0. As you might know, there's a Traefik 2.0 in works, currently still in the alpha phase, if I recall correctly. The integration with both the Cert-manager and the external DNS is currently not working, I believe, but the community is working on that, or I think actually the developers of Traefik are working on that, at least on the external DNS. You might work around the Cert-manager by creating the certificate upfront, as I've already shown you. So you should be fine. Basically, when 2.0 comes out, hopefully the external DNS support will be in place, so you should be covered. If not, we're kind of happy to do the pull requests to those two by ourselves, and hopefully those get accepted within the community. Yeah, just don't forget, if you're going to switch to Traefik 2.0, as we've run a few preliminary testing, revise a few of those performance aspects that I was mentioning earlier, as the 2.0 version is really different in terms of like how it's processing the updates to the CRDs, and given it's not right now, it's not using the Ingress spec definition, and so it's using way less resources. So you might scale down your deployments after switching to that. And yeah, that's it. I mean, a few links. The first one that's for the GitHub repository with all the deployments and everything. So take a look there if you're interested. And yeah, the other ones are leading to the documentation about the integration with the external DNS, with the Cert-manager, and docs Traefik as well. And that's it. Thank you.
Nice work, Jakub. Thank you so much, and thank you to everyone who showed up today and hung out with us. As per what Jakub said, we will be sharing we will share this online meetup via YouTube, and also I'll send it to all the registrants, and we can share those links that he provided in his slide deck, or share the slide deck actually. Cool. So in the chat box, I put a link to our upcoming webinar with Rocket Chat. It's Aaron Ogle. It will be on the 30th. And we're going to talk about Amazon, what is it, EKS, and how they're using Traefik with that. So thanks very, very much. And Jakub, if someone wants to get in touch with you, is there a way you prefer them to reach you? Or, well, we can probably have them contact me through the email send. So
yeah, absolutely, or they're on like Traefik, Slack or so, I'm there as well. So yeah, or Coufal, or so. So yeah, can get in touch, or yeah, on the GitHub there's link for my email or LinkedIn.
Yeah, if you can find them through GitHub or Slack, then you can find all that other stuff. So
exactly.
in the virtual world, sometimes we do a virtual fist bump to the thing. Thank you so much, Jakub. Nice work. And thank you, everyone. Have a wonderful day.
Yeah, too. Bye.
Bye-bye.